I think we're good to go. I've just had a look. Hello to everyone who's joining us on LinkedIn, on Facebook, on Twitter, and of course on Livestorm. As Pierre said, today's webinar is all about automated IoT testing and is it a game changer for product quality? And we're going to be looking at our very own software accelerator, Pluma. I'm really excited about this one. I think we're going to learn a lot. So just a few kind of housekeeping things to say. If you are watching us on any of our socials, hello. You can answer and ask questions in the comments and I'll be able to see them. And at the very end of the webinar, we'll be doing a live Q&A. So if you see anything that you're like, oh, I want to know more about that, then just kind of put your comments there. And the same as Pierre just said in Livestorm, you can do the same in the corner and we will answer them at the end. If you'd like to know more in general about Pluma or any of our software accelerators, drop me a line in the comments and or send me a message and we can send you some flyers and some spec sheets and marketing materials, and everything will be anonymous, of course. So without further ado, I will hand you over to our lovely and capable speakers, Pierre and Julien.
Thank you, Georgie, for this introduction. So let's maybe introduce ourselves. So I'm Pierre Gall. I'm Solution Director at Witekio and working at Witekio for now 15 years, playing a lot of different roles from low-level developers to manager of a team, and now building the IP strategy for Witekio, where we are currently building some accelerators for our development, and we will present to you one which is named Pluma today. With me today for the technical part of the automated testing, Julien. Julien, can I let you introduce yourself?
Yes, so hello everyone. My name is Julien Vielle-Tambay. I'm the lead developer on Pluma, and Pluma is our in-house built automated IoT testing solution. Later in this presentation, I'll give you a quick tour through its current capabilities. That's why I'm here.
Perfect, thanks Julien. And let's go for the presentation. So we will start with a quick introduction about software, and more particularly about the complexity of software. During all my career, I see a lot of different types of projects, and what is clear is that software is becoming more and more key in the development of product, of embedded product, of connectivity solution, of IoT solution. So as software is more and more complex, testing it become also more and more complex. We identify two types of projects today: what we call low feature software, maybe more concentrated on a microcontroller with less functionalities, and what we call also feature-rich software that integrate a screen with embedded UI, with connectivity, with an important stake on security. And now we are just starting to see projects with embedded AI. So as you can see in this global graphics, the complexity is more and more important. Maybe we can introduce some terminology before starting the detail of this webinar. The first one is about IoT. So what does IoT really means? I will just do a quick introduction for our today webinar. We can spend days just talking about that. But IoT for today means an equipment that could be a low-end MCU-based device, or it could be a MPU high-end device, which is connected to a central IoT solution. We call that IoT hub, with one or multiple business applications that allow customers, users, to answer to a business need with this equipment. On top of this IoT and local services, in lot of different use cases, we can see that this IoT services is connected to the internal tools, to the internal IT and OT ecosystem of the company. I mean, for example, the customer base, the customer database could be directly extracted from the CRM. So as you can see here, IoT means a lot of layers. That means a lot of different softwares. So that means, once again, a complexity for the testing. I'm talking about testing, and I think we need to all align on what really testing means, once again for today, because that's a long and complex topic. And I try to summarize what testing means in the famous pyramid of tests. We will build it step after step. So the first level, the basics level, is what we call unit testing. It's a fully automated solution that is where the objective and the meaning of this test is to validate a very specific part of the code source, a specific algorithm, a function, testing with different parameters, and validate that everything is working as expected. The second level is what we call component tests. We are here starting to test more global features, like a full driver on embedded in an embedded part, or a complete service on an IoT platform or business logic specific field on a UI app embedded or not embedded. On top of component testing, we talk about integration tests. Integration tests mean how my system behave when I start to assemble multiple components. So you have some interesting example like OTA update. I mean, over-the-air update of your embedded system. It uses an embedded feature. It uses a cloud part to upload a firmware. It needs a connectivity to download the firmware. It needs another connectivity to report a new value. So there is multiple layers that are integrated into this integration test. And on top of this pyramid, there is a system test, which is a full act as a user testing that will validate all the complete and different business features of a solution. Embedded, cloud, or both of them, full IoT solution. What is important here is about manual testing, on-board, off-board. So unit tests, we don't talk about unit tests today. It's more something that you can do automatically, directly integrated into your continuous integration with very dedicated tool. We call that off-board automated testing. So you do it automatically, but you don't do that in situ in the real integration environment. For the other layer, you have two different ways of doing the tests. You can do onboard automated testing. I mean, testing stuff in an automated way, but on the real hardware, on the real cloud environment. And some of the tests can be done manually. For sure, we will see that manual test is something key in a development of a solution, of a product, and it remains something really important. So we differentiate both manual testing and onboard automated testing, and we will really concentrate today on the onboard automated testing. Another interesting information we'd like to share today is about the duration between the development and the test. And if you are in the unit test, you discover the bug during the night that follows the development. So fixing this bug is really quick and is really easy because you can definitely, or you already have in mind how you develop these features. For the system tests, that occurs often at the end of the product development, or at least at the end of an iteration. It's become a longer period between the time you develop and you do the test. So for the development team, it could take more time to fix the issue. And I think one of the key topics in automated testing solution is to be able to discover the feature earlier because you are implementing the automated testing as soon as possible. For sure, for the full system testing, you can do a miracle, but just think about testing it as soon as possible, help to discover the bug earlier, so help to reduce the cost of bug fixing. Now we will talk about automated testing. So what automated testing allow us to do? All the normal behavior testing, what you can do with a manual testing, normal behavior testing, edge case management. It can also help to ease the non-regression testing because you can do it manually, but you can do more or less a big part of what can be done manually. I mean a big part, but not everything. You have to be careful with that. What is important with automated testing is that it brings new capabilities in terms of testing, like endurance testing, robustness, performance measurement. And this is really important because a part of this test could not really be done manually, or it could be done, but with a long time, it could cost a lot, and it could be not so easy to reproduce each time you want to test it. So automated testing really bring an added value in this part. And automated testing in IoT, in fact, as we said before, IoT finally just bring complexity in the project. So automated testing will help to fight against this complexity, and you will be able to test embedded software, driver, operating system, connectivity, cloud platform, and all the different layers of a system. Let's try to see what does that mean from a cost point of view if we compare manual and automated testing. That's just a rough graphics. It's not an absolute values. In the vertical axis, you have the cumulative cost of the test, and on the horizontal axis, you have the time of the project. And what is important to see is that at the very beginning, when you start the development, you do some small manual steps in your project, so it costs less to do manual tests. And building all the automated tests, putting in place the testing, the automated strategy, tooling, will take more time at the beginning than manual testing. But we are between mid and the end of the development. Having an automated testing suite will help you to reduce the global cost of testing, because you will be able to run it again and again for a really low cost. Now, we are developing a solution named Pluma that helps to put in place automated testing. So the question to answer is, why do we have implement such type of tools? Because definitely we don't find any satisfying tool on the market. You can find very specialized tools. For example, you have tools for low-level Linux specialized test suite, but you can do only Linux testing. You have tools for API testing. You have tools for specific protocol testing, but you have nothing that are able to integrate all the different layers and allowing you to perform this global IoT testing. And that's why we start working on these tools that at the beginning was an internal tools, something like 5 or 4 years ago. And we want different major features. We want to be able to deploy the embedded software directly from the test tools, to be able to really integrate the test in the continuous integration and become ready. CT means continuous testing approach. Then we would like to be able to run a large set of actions. We have pre-integrated actions. You can develop your own actions. These actions are the real test actions that an operator can do when he is doing testing manually. But we also would like to act as an orchestrator. For example, for testing API, you have a great tool, which is Postman. And it really makes sense for us to integrate these tools, which is the perfect tools for doing testing of an API, directly into Pluma, so that you can enjoy the best of all the different tools for the different part of your project, but everything integrated into a unique tool. We would like also to integrate measurement, or also what we call metrics, to be able to say, okay, how many time my boot take, and I can measure that all along the development of my project to be sure that there is no deviation of this boot time during the development. You can measure the performance of an Ethernet driver to be sure that it is at the expected level of performance. So support measurement, support metrics was a key topic in the product definition. And at the end, we would like to be well integrated into standard reporting system. So we will see in the demonstration that we support Excel, but we also support test management application that you can use in your test strategy. What does that mean regarding the costs? We just try to make the automated testing as quicker than if you try to build on your side the automated testing suite. So we are building what we call accelerators. This is the name of the initiative I am leading at Witekio. Accelerators is here to enhance your time to market and reduce your cost for your project development. Before letting Julien give you more insight about the technical part of the automated testing, I would like to do a quick introduction about test strategy, because we see too much of our customers not really organized, not really doing this first step of a product development, which is a test strategy. Now, we can spend hours talking again about test strategy, but I just would like to highlight 5 major topics that needs to be integrated into the test strategy. The first one is about the global test approach, the test level you want to implement. I would like to do unit tests, yes. What level of coverage I want. I would like to do automated testing for the global UI. I would like to do non-regression testing. You define the global test approach. You need to define the correct role and responsibilities of everybody in the project. And in the test, there is not only the lead test and the test team. Integrator and developers are also part of this global test strategy and have a role to play into this product quality approach. Next topic is about the environment definition. Do I need a simulator? Where do we plan to run our test? Do we have evaluation board? Do we only use final hardware? What's our environment for the test look like? We will talk about test reporting. I was talking about test management application, but there is also different type of KPI you would like to define, like code coverage, like coverage of story, or coverage of specification you want to cover with automated, with manual testing, performance indicators you want to reach. So define the global testing reporting and the KPI you want to follow up is also something important in your test strategy. And at the end, you will have to define the correct tools to use to achieve this test strategy. So do you need an automated testing tools? What kind of simulator do you want to use? All the tools you need for achieving this product quality is in fact something that is key in your global test strategy. So now you know better how you can define your test strategy. Let's finish with some example. Refocus on automated testing before Julien give us more detail. I try to reuse the same pyramid. So the first level is component testing. So what can we test automatically in a component test layer? But let's take the example of a non-flash driver. I don't know if you are familiar with embedded system, but it is a type of a flash, of ROM storage. You can imagine read and write cycle. You can imagine checking bad block. You can imagine random access. You can measure the performance in read, the performance in write, the global robustness of the driver. So there are a lot of different possibilities you can do automatically at this component level. Another interesting driver to test is a Wi-Fi driver. For example, in Pluma, we integrate the control of a router. So we are able to set up fully automatically a complete infrastructure of tests for Wi-Fi. So we set up first in open authentication, then a web authentication, then a WPA authentication, WPA2, and we do that for all the channel and sub-channel. And for all these different modes, we are able to measure the performance, the global endurance, and have a global report. So our Wi-Fi tests take hours, but at the end, you have a global overview of the capabilities of your Wi-Fi driver and also the global performance of this Wi-Fi driver. If we move to a second level, integration testing, I talked just a few minutes ago about boot testing. So there is a boot robustness testing, which is really important. If I try to boot my product about 100 times, what's happened? Just for a small story, we do that on an IMX8 NXP BSP a few months ago, and we discover that once every 800 boot, the GPU driver does not boot correctly the system. So there is really an added value of doing such type of reboot and endurance testing. The other example I take is about firmware update. Firmware update is a complex operation that takes time to be done manually. Here, with a good tools, you can upload a firmware in your cloud, ask your embedded device to update it, then check on the embedded part if the device have been updated correctly, then check on the cloud that the device report correctly its current firmware version. So this is the type of test you can do easily in an automated way. And at the end, there is a system testing. So here is more the manual world, but you can do a lot of different, for example, UI testing. We have a feature included in Pluma to click on a queued button. So I click on button 1 and check if the text box have the correct value or stuff like that. That could be also an added value. And all of these 3 types of testing are really the pillar of a global product quality. So for the question, is automated testing a game changer for the product quality? I don't would like to spoil the final slide, but yeah, it definitely helps to increase the quality of a product. Now, I do a global presentation about strategy, test, automatization, and IoT. I will let Julien give you some example of test in automated way with some example based on Pluma. Julien?
Yes, let's go. All right, so more details on Pluma. So what's Pluma? It comes as a command line interface tool. So it can be run on a Linux environment machine. Please, Pierre, just pass the slide. All right. So as inputs, it will take YAML configuration files that are quite high level. It would take a test plan that would define each and every action you want to test your device with. And then it would also take a target definition. So that's where you would find all the connectivity information you need to address your device. So from there, Pluma will execute and produce you and provide you with multiple results, logs. The first and main one would be the JSON results. It will list status for each of your tests. It will list some stuff like duration of your test, etc., etc. Maybe persisted data. Aside from that, you would get raw logs. So those would be what happened on your shell, on the host, what happened on the device shell if you opened any, and also more straightforward, more exploitable outputs that you could open right away would be the Excel reports. So from just a glance, you could see if everything is going well. And also you could even integrate with reporting tools like X-Ray. So from now, I get you through the main means of interaction we got with Pluma to test the device. So I start with the most straightforward ones, the core interactions that we call call interactions, the more direct one. So let's say I've got a device, a DUT, a device under test that I want to test that supports a shell. So first, I'll open a console to it. I'm going to start writing commands to it, read the outputs, and expect specific values. Aside from that, I can use specific entry points. That's a more indirect means of testing my device, but I could test the device environment. So I could manage the power of the device. Let's say my device is powered by a power distribution unit. So I could turn on and off my device from there, from Pluma. I could emulate some storage space on the device. I could even flash firmware if I've got a JTAG between my host and my DFT. I'm going to give you just a quick example. So I've got a host, a device, and a power distribution unit. Everyone is interconnected through the local network, and the power distribution unit is powering my device. Here in this example, my device is a MX8. It's expected to run some Linux Yocto-based image, and I want to assert that the kernel version is 5.10 point something. I know it's up on .1.xx on the local network. I also got details about my power distribution unit. So it's an IP power 9258. It powers the device through its first outlet, and I know it's up on .1.yy. So what I need on the host side, Pluma would need a testing plan and a target definition. So how does that look? The test plan is really simple here. It's a simple test named assert kernel version. You can see three main blocks in that test: a setup, a sequence, and a teardown. So first, to be able to test my device, I want it to be powered on. So I send the power on command to the PDU, and I wait for 5 seconds. So I'm sure that the device is up. After that, I'm going to run some actions. So first is a run on device action. What I'm doing is just I'm going to run on the device a uname-srm command, and I'm going to run another action which is a check. I'm going to check that the command output contains 5.10. It's really naive here. After that, I'm powering off the device again. The target definition here, it needs to contain all the connectivity information on both my device and my PDU. So to interact with my device, I'm opening a secure shell to my device. So the target is .1.xx. I'm giving the target credentials as well. I'm doing the same thing for the power distribution unit. So here I'm stating that power management will be done through the PDU daemon tool. I'm specifying where to address the PDU, the outlet to use to power my device. And I need to provide the driver and the credentials of my PDU. Okay, so that's it for first example, just testing the kernel version of a remote device. Another mean of communication we have to test a device would be the protocol communication tests. Here, Pluma does not interact with the device as such. Instead, it interacts with the host interfaces that are somehow connected to the DUT interfaces. So here we expect, depending on the protocol, a specific connection. It could be a serial connection, an Ethernet connection, a Bluetooth connection, anything. Today, I'm going to show you an example with the BLE protocol testing. So the Bluetooth Low Energy Protocol tests capabilities that we have. So in this particular protocol, what Pluma does, it's that it interacts with the BlueStack on the host. And it's going to test the behavior of a device acting as a Bluetooth server, as a GATT server. So what our example will do, it will like flash a new firmware to the device through our OpenOCD wrapped actions through a JTAG that needs, in this case, to be OpenOCD compliant. And then I expect my device to be up in Bluetooth to advertise a specific name. It should be named BLE device, and it should expose a given characteristic from the value. Sorry, the value needs to be hello world. All right, so here the test plan is going to be a bit more complex. We are going to do more stuff than before. So I'm defining a name for the test, which states itself, and I'm defining multiple variables. So I don't have, each time I want to specify the device ID, to write it as such. So my device ID, I said it was expected to be named BLE_device. I'm specifying a specific characteristic and also its values. So here's this byte array translate to hello world. That's the value I want to assert in the specific characteristic. And then I start my plan. So the setup would be flashing the new firmware to the device. So I start an OpenOCD session. I write a specific file I flash a specific file through the JTAG. So here I expect my firmware file to be in the current directory, in the execution current directory, and to be named ble_device_firmware.bin. I'm ending the OCD session, and I can start my test sequence per se. So I'm going to scan for available device around my host, and I'm going to check that BLE device is up. All right. From there, I'm going to try to connect to this device, and I'm going to read the value of the given characteristic that I specified earlier. Here, I expect it to be hello world again. The target definition here, you can see it doesn't define any connectivity information because it only needs to define which specific resources Pluma needs to use in this plan to be able to use specific actions. So I want to flash using OpenOCD, so I need to specify that with OpenOCD_local. And also I need to specify that I want to use the wrappings of the blue stack. So I'm specifying the BLE resource here. All right, that's it for the example on protocol communication. And now moving to the last interaction mean I want to present will be the cloud platform interaction. So the host on Pluma will send HTTP requests, would be able to run Postman collection on a given platform interface, cloud API, something that would interact with one or multiple devices there. For the example, how does that look? We've got a host, which is a Raspberry Pi. We've got the DUT on the other side, which is an ESP32. And what I'm going to test is that the platform is able, through MQTT, to turn the LED that is connected to the DUT JBA on and off. To assert that the LED is on and off, my host will also be connected to the same LED. So let's go through
maybe just a few words on this example, because it is really a very interesting example of IoT full stack integration. Here you can see that we are able to interact with an IoT solution, central cloud platform. We are able to interact with the hardware locally, and it is a very basic use case. We just check a LED, but you can imagine very more complex test case with, as I said before, a TA update or checking some sensors value, checking frequency of message received by a cloud platform, and so on and so on. So that's really a strong added value of this global IoT tools to be able to do this entire solution. I also just take a minute to talk about this platform interface we are talking here, which is KMEA, which is one of the other accelerators we are doing in the accelerator initiative, which is an IoT data integration and device management solution we are doing in the same way of accelerators for our customers. But that's another story, and we will probably have a webinar in the coming weeks on this topic.
Yeah. All right. So we can move to the test plan and target definition. So here we're starting with the target definition explanation. So I said we need to be able to interface with the host GPIOs. So here we can see that I'm saying that I can control the LED state through the pin 21. From there, in my plan, I will be able to test the LED state. So on my test, first thing I'm doing is asserting that the LED is off. I'm turning the LED off so I can run my test. Then once I'm sure the LED is off, I'm sending a first request to the platform. Here there is a number of parameters, namely the URL to it, the action, and you can see in the post data that I expect the LED state to be 1. So once the request is sent, I'm waiting for 5 seconds. So I'm sure that the platform will be able to process the request and the device will turn the LED on. To assert that the LED is on, I'm doing a a read from my host GPIOs, and I expect the LED to be active, to be up. Again, I'm sending a new request, and this time I want the LED state to be 0. I want the LED to power down. After I send my request, I wait for 5 seconds, same thing. I'm waiting for the platform to be able to process the request. And then I'm reading the GPIO value again. So here I expect it to be powered down. All right, so that's about it for the examples and the current capabilities of Pluma I wanted to highlight. Moving to the logs now. Earlier, I told you that Pluma outputs contain multiple logs. So we're going to start with the raw logs. Here is the first log you're going to get after each execution of Pluma. It's the host console log. So it's what's directly the output of Pluma. So in your console, it would look like that, and you're going to get a log file corresponding to that. Here, the value is just to keep a trace of what happened. So you can see the multiple actions that were run, and either the action passed, the test corresponding to the action passed, and the whole plan passed or not. Aside from that, you're going to get, if you open the console to the device, you're going to get a corresponding log. So here in the first test I've done, which was the assert kernel version, I opened a secure shell to my device, and you can see that on the device, a uname-srm command was run, and you can see its outputs. All right, so that's it for the raw logs. Moving to the more exploitable logs, the JSON results. It's a file that will contain every details about the execution, and you can see it's made up of 3 main blocks. The data block, which is the persisted data by each and individual action. So an action can persist data to this file if it needs to. Under that, you can see a settings block, which will be more a description of the plan we run. So I didn't name my plan earlier, so it falls back to default plan. I ran a single test. It was named assert kernel version, and 2 actions were run. The run on device action and its parameters. So it's just the uname-srm command, and the check action, which by default checks that the expression we saw was true. Okay, the main block is the results block. It will give you information on either the execution is a success or not. Is your plan a success or not? The start time of the execution, the end time. And for each test, it's going to give you the same information, like start time, duration, does it pass or failed. It would really expose a number of information. Here, everything is folded down, so I can get you through it, but it would need many slides to go over the entire JSON result file. All right. Also, you get, if you ask for it, an Excel report. So here it's also the same test, very simple test. There is a single test run to the device. So you can see the number of success tests, the skip test, because on very big plan, you can mark tests as to be skipped, the number of failed tests, and also start time, duration, etc. You can see under that there is 2 tabs in this Excel file, a test result and a test metrics. So if your test generated any metrics, here my assert kernel version does not. But imagine that Pluma is plugging in a CAN bus from a device. This device has multiple nodes communicating through this bus, and Pluma captured what happened on a single CAN ID. It would generate a metric like the reception time intervals, so how many time passed between 2 messages received from the CAN ID. And I want it to be, let's say I want it to be every 100 milliseconds. So here I can see the mean value. I read the max value and the standard deviation. So even if the mean value was correct, here from a glance you could say that something is happening, something wrong is happening, because you get a standard deviation that is too big and that doesn't fit your expectations. All right. Just last, I earlier said you could integrate with reporting tools like X-Ray. So here, how does that look? For plan, in X-Ray, you will find for the logs produced, any Pluma output would be sent as attachments to X-Ray, and you could see the overall execution, so how many tests passed, how many failed, etc. All right, that's it for me. Thank you for listening to me. We're going to get back to Pierre for the next slide.
Thanks, Julien, for this detailed presentation. So yeah, we have a lot of features that we could not demonstrate on Pluma. We have the core Pluma that are able to control UI, doing some concurrency testing, measuring metrics, helping you to measure some stuff. We have two extensions, one dedicated for Linux with the Wi-Fi test suite, for example, and one dedicated for protocol test suite. So yeah, if you need more information, don't hesitate to contact us. We will be happy to make more specific demonstration for you or for your team. We are now at conclusion. So the key takeaway for this webinar. So is automated testing a game changer for product quality? Yeah, for sure. The response is yes. It allows not human doable testing type like performance testing, endurance testing. We are able to do reproducibility very, very well. It will empower the development team in the product quality because you will be able to give the development team tools to prepare some ready-to-go test for the QA team. So you can embed more all the different roles of your project. It will help to early bug detection. So that means cost reduction of the global development. It will also integrate the test more in your day-to-day. With, for example, a nightly automated testing that will give every morning some KPI on the quality of the project. But, because there is always a but, it is not replacing human. You need to keep your QA team, that people are key for the global product quality. Tooling is just tooling. So it's how you use it that will make the quality of your testing. So important to correctly use it and to correctly know what you want to test and correctly define your test strategy. We were talking about before. It will never replace some type of manual testing, like for example what we call exploratory testing, where a QA guy are just doing using the application as a standard user, doing random stuff, and this will be always necessary to deliver a global project. And just a final word, QA are just evil genius. So they are able to find the right small detail on the projects that are not doing as expected. So please concentrate your testing strategy not on testing or on tools, but on having the right guy in the QA team. So think testing at the very beginning of your project, correctly build the test strategy, prepare full test plan, non-regression testing, and correctly structure this test strategy, and you will be able to enhance your global project quality. That's it for us today. Thanks a lot for listening, for joining us. You have our contact, telephone, mail, and LinkedIn if you want to join us. We will be really happy to discuss a little bit more about what we can do and how Pluma can help and what WeTechio can do for you in terms of product development and quality. Here is a link to our whole software accelerator webpage. If you have any question, please use the integrated LabStorm question system, and we will be happy to answer.
Thank you, Pierre, and thank you, Julian. Yeah, I was going to say rounding up, but we're not rounding up. We're here for your questions if anyone has some. I've got a couple that have been asked before because I sent emails to everyone saying, do you have any questions? Let me know. But I particularly like that you called QA evil geniuses. I always recommend hiring any kind of evil genius is good to me. So that's always good. That's the takeaway. Hire an evil genius and then buy Pluma. Some of the questions that we've had asked, as I said before, and guys, please ask questions if you've got any in the chat and I will answer them. So the first one is, if Pluma doesn't support the feature that you want to test, how can you manage that?
Yeah, good question. In fact, Pluma is written in Python, and everything has been designed to create extension. So what Julien demonstrate with action, like run on host, run on device, checks, you can write your own in Python. The entire source code of Pluma is available. So when we deliver Pluma to our customer, in fact, we are delivering a source code. So there is no vendor lock-in. This is also the software accelerator strategy. So you will be able to extend very, very easily with your own test case written in Python to fit your exact needs in terms of testing.
Got it. That makes sense. So it's not the end of the world if you don't have the exact one, you can add it. Okay, and then the next question is, can you give us some real use cases using Pluma in the industry? So obviously it's been launched, and how is it being used currently?
Yeah, sure. I can't name the customer name. I can't use the customer name, but we are working in a lot of different industry. We are using for home appliance solution, coffee machine. We are working in the pure industry with industrial sensors, like level sensors for industrial process. We are working for workout equipment, many. We are working for small startup and big group. So there is definitely no standard type of project because testing and software quality is key for everybody, from the small SME to the major multinationals that are doing a big product.
Okay. And then the final question that I've got here talks about when automated testing is most important. So, you talked earlier about the different levels of testing. So when is it most important that you need it?
I try to share that in the slide. In fact, as I try to say, idea is to concentrate your effort on automated testing for the component and the integration testing. I think the component is maybe the more easy stuff to set up, because you take a driver, the input, the output, you can create measurement stuff, and you can really concentrate your effort on having this specific component, this specific driver or feature tested. It becomes really powerful when you are doing integration testing, as we see in the demonstration with the LED, the GPIO, and the platform. We are able to validate a global scenario of connectivity. So it's really easy to do, and with a lot of added value. It becomes more complex for the global system testing, even if you can do some UI interaction, for example, with Pluma.
Perfect. I think that is it currently for any questions. This is the last call if anybody else has any. I'm just going to double check. But thank you so much, Pierre. Thank you, Julien. You've been fabulous. And and I hope everybody out there has learned a bit more about our software accelerators, and in particular, automated IoT testing with Pluma. I will speak to you all later. Bye.
Thanks all. Thank you, Georgie. Bye-bye.
Thank you. Bye.
Bye-bye.